All right, welcome back to Math with Miss Leslie. Oh gosh, I'm going crazy. Okay, so today we are going to do polynomial division. All right, so this is our next segment of polynomial and rational functions. And I think this is a pretty cool day. I think that polynomial division makes a lot of problems much easier to do. So hopefully you guys find this as fun as I do. All right, let's get into it. All right, so first off, our last video was all about factoring, different types of factoring for polynomials and things like that. But some people still really don't understand what it means when we say we are factoring something. All right, so I want to kind of start by talking about what is factoring slash what does factoring tell us about what we're dealing with. All right, and you guys have been doing factoring way before you ever got to algebra. You were doing factoring when you were dealing with numbers in elementary school, like 36. So when we say we are factoring something, we are breaking a thing into its different multiples. Okay, so factoring is basically taking a number, a term, or even an expression. Nope, that's not right. Taking a number, a term, or expression down to its smallest multiples. All right, let's just pause this video real quick because no writing is showing up. Okay, the writing is showing up now. I was writing on the wrong page. It's fine. Okay, anyways, this is what we've got going on here. All right, so basically factoring takes a number, a term, or an expression, and it breaks it down to its smallest multiples. All right, it gives us like the bare minimum of what multiplies together to make the thing that we have. So like I said, you guys did this in elementary school when you were dealing with numbers. So for instance, if you have the number 36, you were kind of taught probably to, since you didn't have calculators, and 36 for a third grader is kind of a big number, maybe you were taught to break this down into like using like a factor tree, right? So 36, well, that's 2 times 18. Cool. 18, that's 2 times 9. Cool. 9, that can be broken down too. That's 3 times 3. So when you're factoring a number like 36, it kind of looks like this, right? So you could say that 36 is 2 times 2 times 3 times 3. That is factoring with just a number value. All right, we can do the same thing when you move on to, say, I don't know, maybe 7th grade math, and you have, sorry, my dog is being very loud right now. She's itchy, I guess. I don't know. She has nothing to itch about. Summer, stop that. Yeah, go somewhere else. All right, so like I said, when you moved into 7th grade, you had another type of factoring, and that was when you added in a variable. So with the number, it's kind of the same thing, right? So we're going to take 12, and you would say, oh, this is 3 times 4. Oh, 4, that's 2 times 2. X squared, well, that's x times x. And y is just y. So I can rewrite 12x squared times y using its multiples, which would be 3 times 2 times 2 times x times y. Those are the factors of 12x squared y. Now, when we moved on to Algebra 1, you guys learned how to factor expressions using your quadratic factoring techniques. All right, now it does work a little bit different. We can't just use a factor tree. We do more of like a factor box, right? So we use like this box method. All right, we put our first term, x squared. We put our last term, the negative 28. We say, okay, what things multiply to negative 28 and add up to 3? 7 and 4. All right, so we have 7x, we have a minus 4, and then we kind of reverse that by pulling out these multiples. But what we get at the end of the day is something that says that this expression can be broken down into x minus 4 times x plus 7. It won't let me scroll anymore. There we go. It's kind of squished, but you guys get the idea. All right, so those are the two things that are going to then multiply to make this polynomial, or this expression that we have right here. Okay, so just remember, factoring tells us what the bare multiples of our function is. Now, what we also can do is we can take a function and say we know what one of the multiples is. All right, say we know, for instance, if we had a number, say we know that the number, maybe we don't know all the multiples, but say like 100. All right, we know that 50 goes into 100. So if we can divide out by 50, then we can kind of find the other numbers that are going to kind of go into 100, right? So division, if we know one thing to divide by, that can help us figure out other numbers that will also be divisible into something. And that's the technique that we're going to use when we're doing polynomial division. So the idea is, if I give you one thing that divides evenly into a function, you can use that one thing, divide it out, and then hopefully be able to find your other multiples based on that simplified version of the polynomial. All right, so we're going to look at types of division. All right, there are two main types of division. There's long division, which you guys did with numbers. So we're going to look at a number example, and then we're going to do it with polynomial. There's also a new type of division that we're going to talk about. Some of you may have learned it in Algebra 2, some of you maybe not have. It's called synthetic division. It is very quick. It's a lot quicker than polynomial long division, and a lot of people tend to like synthetic division more, but other people will kind of stick with long division because it feels better to them. So we're going to do an example of long division with numbers, and then we'll walk through a very similar problem when we throw in variables so you guys can kind of compare and contrast. All right, so we'll zoom in a little bit right there. All right, so with numbers, we have 672, we want to divide it by 21. What we do is we take the 21, we write it out front, we put our division sign, and then we put 672 underneath. All right, then we start with the first number. We say, okay, can 21 go into 6? The answer is no. So then we go to the first two numbers and we say, okay, does 21 go into 67? The answer is yes. Now I need to know, how many times does 21 go into 67? Well, you can use a calculator if you need to, but I'm going to do this by kind of hand. So 21 to 67, I think it's going to go in 3 times. So I put a 3 up top. And now what I do is I take that 3 and I multiply it by the 21. So 3 times 21 is going to give me 63. The next thing I do is I subtract. Oops, get rid of that. I don't need that piece anymore. I subtract. 67 minus 63 is going to give me 4. Then I bring down my next number and put it right here. And so it's a 2. So now I start over. Now I say, okay, does 21 go into 42? The answer is yes. So then I say, okay, how many times does 21 go into 42? The answer is 2 times. So I write a 2 up top, and then I multiply. I say 2 times 21, and I'm going to put that underneath of the 42. Well, 2 times 21 is 42. All right, so then I subtract. 42 minus 42 is 0. So I have a remainder of 0. So the answer to this question right here, 672 divided by 21, the answer is 32. That is division with numbers. Now, it is a very similar technique when you're doing this with polynomials. So just remember the pattern. We said, okay, how many times does this go into this number? It goes in this many times. We write it up top, then we multiply, then we write that number underneath, then we subtract, and then we repeat. That's the exact same technique we're going to use for polynomials. Okay, I have the hiccups. All right, so let's do it. Let me move this over a little bit, actually. I thought it was going to take up more like this space, but it didn't. Okay, here we go. So we're going to start off by writing the number on the bottom. So 2x plus 1 out front, divided by, and then we write our 6x squared plus 7x plus 2 underneath. All right, so I'm going to look at my 2x and my 6x squared and say, okay, how many times does 2x go into 6x squared? Well, 2x, 2 goes into 6 3 times, and x goes into x squared once. All right, so next what I'm going to do is I'm going to multiply. So 3x times 2x, that gives me 6x squared. Now the next part that's different, because we do have this plus 1, we're also going to do 3 times that plus 1 and also put it in there underneath. So 3x times 1 is plus 3x. Now we subtract. And we want to make sure that we subtract everything. So it's the 6x squared minus 6x squared, which makes 0. So that's going to go away. And then 7x minus 3x, which is going to give me 4x. All right, now I bring down my 2. So I bring down my plus 2. And now I just repeat that same pattern. All right, so I'm looking at 2x versus 4x. So 2x times what is going to give me 4x? Just 2. So I do a plus 2 up top. All right, and now I multiply. So 2 times 2x is 4x. I also have to do it to the 1. 2 times 1 is 2. Now I subtract. 4x minus 4x is 0, so that's going to go away. And then 2 minus 2 is also 0, so I have a remainder of 0. So to answer the question, what is 6x squared plus 7x plus 2 divided by 2x plus 1? The answer is 3x plus 2. Now, with polynomials, it's nice that we can do this because now we can write this in factor form. So we originally had 6x squared plus 7x plus 2. Well, 6x squared plus 7x plus 2 can be rewritten or factored to 2x plus 1 times 3x plus 2. So by dividing out one of the factors that we were given, we were able to find the other factor, which is kind of nice, right? We know that these two parentheses multiply together to make that 6x squared plus 7x plus 2. So that is why division is so helpful, because sometimes you might know maybe 1 or 2 of your factors or your zeros of your function, but maybe you just don't know the other ones. And so if you have to find them all, taking the ones that you know, dividing them out is then going to allow you to be able to find maybe those missing factors. So it's a really cool technique for getting a polynomial into factored form, which is what we're going to use it for. Now, like I said, there is another type of division that we are going to look at, and it is called synthetic division. We're going to do the exact same problem that we did above. So it's still the same 6x squared plus 7x plus 2 divided by 2x plus 1. But what synthetic division does is it does the division without using the variables. Okay, that's basically what it is. So it's just division without variables. Now we are going to put the variables back at the end, but we're going to take them out because it helps us do the division kind of quickly. All right, so this is how it works. Now the first thing you have to do is you take your coefficients for your top polynomial and you write them in a straight line. So just the coefficients. So 6, 7, 2. Now if we had skipped a term, so say maybe it was 6x cubed and then it went plus 7x plus 2, we would be missing like an x squared. We're going to put a 0 in place there. So if you skip a term, you're going to have to put a 0 as a placeholder. That goes for long division also. So if you're doing long division and you notice that you skip a term like in order. So instead of, say, maybe, like I said, maybe it starts with an x cubed, but then it goes to an x just, and it skips over the x squared, you're going to have to put that 0 placeholder in there. Otherwise you won't get the right number. Okay, so we've lined up all of our coefficients, 6, 7, and 2, and then we make this corner box. All right, and what we're going to put in this corner box is not the factor 2x plus 1, but we're going to put the 0 value. So we're going to take this and 2x plus 1 equal to 0, and we're going to use that factor value. So that's going to give us -1/2. All right, and that's what we put in this corner box. So here's the pattern. All right, first thing we're going to do is we're going to bring down the 6. Just drop it straight down. All right, so we bring down our 6, and now what we're going to do is we're going to take the -1/2 in our box and we're going to multiply it by the 6. So -1/2 times 6, so we multiply those together, and that's going to give us -3. We're going to put the -3 under the 7. All right, so we multiply, then we put that number underneath our next coefficient, and now what we do is we add down. So we have 7 plus -3, which is going to give us 4. Now we're going to repeat that pattern. We're going to take the number in our box, we're going to multiply, so -1/2 times 4, and then we're going to take that and we're going to put it right there. -1/2 times 4 is -2, and then we add down to get 0. So we have a remainder of 0. Now, what you're probably noticing is that our numbers are a little bit different, and we're going to get into that in a second. But before we get into our numbers, we need to take what we have right here and we need to turn them back into like actual like factors, right? So we took the variables out to begin with. Now we actually have to go through and we have to put our variables back in. Sometimes this confuses people, all right? But it has a pattern. So this is like our remainder column. All right, so if we started originally with an x squared, every time you divide, you go down by 1 exponent. So if I started with x squared, this 6 now is going to have an x to the first, all right? And then the 4 is going to be just my constant. So it's just going to be plus 4. All right. If I had started with x cubed, then once I divide out by my first factor, it drops down to x squared, then it would be an x, and then it would be my constant. So I would have 3 terms in that case. All right. So when you're putting your variables back in, when you're doing synthetic division, just remember, whatever you started with, you go down by 1, and then it'll go in order from there. All right. So the weird part is, so remember, we just divided the exact same thing that we did above. We took 6x squared plus 7x plus 2 and we divided it by 2x plus 1. Now, when I did it with polynomial long division, you guys notice that I got 3x plus 2. When I did it with synthetic, I got 6x plus 4. Now, this is the same thing. The reason that synthetic division gives us kind of a different value is because we were dividing by a fraction. So technically, what we just did with synthetic division is we took 6x squared, oops, I wrote the wrong thing. We took 6x squared plus 7x plus 2, and the 2 factors we used to divide it was x plus 1/2 and 6x plus 4. So by putting the 1/2 in that corner box, because we had to, right? We had to solve to get what x equaled. It kind of messed everything up, but it's an easy fix, because if you notice, the 6x plus 4 has a greatest common factor of 2. So what we can do is pull the 2 out of the 6x plus 4 and kind of bring it to the front. That's going to give me 3x plus 2, right? So I divided the 6x plus 4 by 2. I just GCF that 2 out front and I put it all the way in the front. And then what I'm going to do to make this not be a fraction anymore is to just redistribute that into that parentheses. So 2x plus 1 and then 3x plus 2. Now I know that was kind of funky, but that really only happens when you have a fraction that you're dividing by. Usually it doesn't happen when you just have whole numbers because there's no reason for it to happen. But if you did have a fraction that you had to divide by, it does have that weird kind of quirky step. All right, but as you can see, we now have the same thing that we got above. All right. So that's synthetic division. I think it's really quick. I like synthetic division. I get that some people think it's kind of strange. All right, so we are going to do another practice problem down here. And I will probably only use synthetic division from here on out because I think it's much faster. So if you are more like partial to polynomial long division, feel free to use that. It does give you more of like a straight answer, whereas you don't, like with synthetic, you have that weird quirkiness where you have that fraction in there. Polynomial long division never has problems like that. So it will just give you straight up whatever your answer is supposed to be. Okay, so let's go to our next practice problem. So this is what you guys are going to be using your division for. All right, so problems like this. So it says, given 1, 0, why did I make this so long? I'm going to go ahead and make it, I don't even know. Sometimes I just wonder what I think in my brain when I'm doing things. There we go. Now it fits better on the screen. Okay, so given 1, 0 of the polynomial, use it to find the remaining zeros and then put the function in factored form. So it gives me my polynomial, so f of x equals 6x cubed minus 27x plus 6, and it tells me that one of my zeros is x equals 2. So what I'm going to do is I'm going to go ahead and I'm going to divide out the one factor that I know, and hopefully I'll then be able to handle the rest of it. All right, now like I said with synthetic division, when you divide out by one thing, it drops you down an exponent. So if I divide out by this x equals 2, it's going to take my x cubed and bring me down one exponent, which will be to an x squared. And then I don't even have to worry about doing division anymore. I can easily factor things that are x squared using my standard quadratic factoring techniques. All right, so it actually is really, really nice that I'm able to divide out 1 because then I will be left with a quadratic, which is going to be easy for me to handle. So, like I said, I'm going to use synthetic division because I like it. If you want to do this on your own paper using polynomial long division, that's your choice, but I'm going to do synthetic. So for synthetic, I'm going to line up my coefficients. Now I am missing the x squared term, so I have to remember to put a 0. That goes for those of you who are using polynomial long division also. All right, so here's my coefficient. So I have a 6, 0, because I'm missing x squared, a minus 27, and a 6. All right, in my corner box now, because it gave me the 0 value, not the factor value, I can just go ahead and put the 2 right into the box because I'm always going to put my 0 in that corner box. So I'm going to put a 2, and it's not a fraction, so nothing strange should happen here. All right, this is my remainder column. It should be 0. So if you don't get 0, you've done something wrong, right? So if you divide something and you get a remainder, it means that whatever you divided isn't a factor of that polynomial. But this one's telling me that it is. So I should be getting 0 for my remainder. I'm just going to put it there because I know that if I don't get that, I've done my math wrong. So I start by bringing down my first number, which is a 6. And now I multiply. 2 times 6 is 12. I'm going to put that underneath the 0. Then I add down. 0 plus 12 is 12. Now I multiply. 2 times 12 is 24. I put it underneath the negative 27, and then I add down. Negative 27 plus 24 is negative 3. Now I go back to my corner box number, which is 2, and I multiply. 2 times negative 3 is negative 6. And I write that underneath the 6, and then I add down. Yes, I do get 0, so I have done my problem correctly. Now what I want to do is go ahead and kind of write this into the factored form that I have so far. So it gave me x equals 2 as one of my zeros. So I'm going to turn x equals 2 into a factor by moving the 2 over. So that's going to be x minus 2. And now I have what I just got from my division. Now remember, I started with an x cubed. So when I put my variables back in, I do one exponent less. So this 6x is going to be squared. The 12 is going to be x to the first. And the minus 3 is my constant. And this is a positive number, so I'm going to put a plus there. All right, so now I can go ahead and put this into the factor. So 6x squared plus 12x minus 3. All right, now it says I need to find the remaining zeros and put it into factored form. So this is factored form, but it's not complete factored form. So what we need to do is we need to check and see if I can factor that 6x squared plus 12x minus 3. And I definitely can do at least a little bit of factoring because there's a GCF that problem has that I can pull out. So that's the next thing I'm going to do. So this has that 6x squared 12x minus 3 has a 3 in common. So I'm going to go ahead and pull that out front. So 3x minus 2. And then this is going to become 2x squared plus 4x minus 1. All right. So now I want to see if this can be factored anymore. All right. To do that, I'm going to multiply a times c. So a times c, which is negative 2. So it has to multiply to negative 2. It has to add to b, which is 4. All right, so can you guys think of anything that multiplies to negative 2 and adds to 4? Because I can't. I don't think it's possible. Multiplies to negative 2, adds to 4. Nope, nothing. So guess what? This is fully factored. All right, so there is my fully factored polynomial. Now I just have to answer that last question, which says to find the remaining zeros. All right, so far I have x equals 2 is one of my zeros. All right, but I need to find my other zeros. So there should be a total of 3 because this was a third degree polynomial, right? 6x cubed. So I should be able to find 3. So I have 1, I need 2 more. Guess what? It's going to come from that quadratic 2x squared plus 4x minus 1. But to get them, I'm going to have to do, you guessed it, quadratic formula. It would have been really nice if it factored. I'm just going to move my head. There we go. All right, so it doesn't factor though. Quadratic formula. So there's 1 0. So we'll just keep track of them. So zeros. There's 1. All right, now we got to do quadratic formula to find the other one. So x equals negative 4 plus or minus the square root of 4 squared minus 4ac all over 2a. Negative 4 plus or minus, I'm going to use my calculator because I want to. 4 squared minus 4 times 2 times negative 1. And that gives me 24 all over 4. All right, now I can simplify the square root of 24 more, all right, because 24 is divisible by 4, which is a perfect square. So I can rewrite this as negative 4 plus or minus 2 square root of 6 all over 4. Now, since I can divide each one of my coefficients by the same number, I can go ahead and simplify. So I can divide all 3 of these by 2. That's going to give me 2, that gives me 1, and that gives me 2. So simplify negative 2 plus or minus the square root of 6 over 2. All right, those are my other zeros. So that is now a total of 3, right? This counts as 1. And this, because it has the plus or minus, counts at 2, which is a total of 3. So those are all 3 of my zeros. So I'm done with my problem. All right, so you guys have some of these problems on your homework tonight where you are given either 1 or 2 zeros of your function, and you have to use division to kind of divide out the ones you're given to see if you can find everything else. I hope this was helpful. If not, I'm sorry. Come during office hours and maybe I can help you some more. All right. I will see you guys in the next video. Bye.